Hey everyone, Mr. Skelton here. We are back at it, lesson 3, unit 5. Today we're going to be dividing and multiplying radical expressions together and simplifying as well as rationalizing the denominator. Let's jump into it. You're going to see some basic problems where we're going to be doing some review, and then we'll get into some more challenging problems as well. So the first slide here, it says to take some simple products. Now, there's a couple different ways you can do this. There are some students who will simplify the 12 first. They'll leave the 3 here, simplify 12 into the square root of 4 times the square root of 3, which is 2 radical 3. And then they'll have basically a 1 here, right? And so they'll have 1 times 2, which is 2 radical 3 times radical 3 is just going to be regular 3, and we get 6 for our answer. The other way to do it, option 2 is to times 3 times 12. As long as this is a square root and this is a square root, you can times those together to get 36, and we all know the square root of 36 is just 6. So in both ways, you do get 6 for an answer. Same thing when you have cube roots, as long as they are the same, as long as they have the same index, right? So this would be the cube root then of negative 27. We can multiply those two together, and the cube root of negative 27 is negative 3, right? Negative 3 times negative 3 times negative 3 is negative 27. Moving on. So now we're going to do some simplifying. This first one here is we're just simplifying this, and we did some of these in lesson 2. Here is one where you have some options, and we'll talk about number 4 when we get there. So always check the index, right? This is the index of 3, and we're taking the cube root of 54. So I always check just to make sure in my calculator if I can actually take the cube root of 54. If you remember from yesterday, we went the 3 and then second or caret button and then 54, because you never know what could happen. Well, it doesn't work. I get a decimal, so that means I'm going to have to break down 54, right? So 2 and 27, 9 and 3, 3 and 3. Always circle my prime numbers. And again, we're looking not for pairs, we're looking for groups of 3 because it's the cube root. So I'm looking for groups of 3. If there's a group of 3, so I have a 3 here. Now I'm going to leave a little bit of a space. I'm going to put my cube root here, and I'm going to put this 2 back inside. Now the reason I leave the space is because now I'm going to focus on the letters or the variables. So this is x to the 4th, and if you recall from lesson 2, I'm taking the cube root, so I'm looking for groups of 3. Well, there's only, if you take x to the 4th, there's 4 x's. There's only one group of those. So that's one group of 3, and then the leftover one goes back underneath the cube root symbol. Y to the 3rd, there's only one group, and so there's no leftovers. Again, if you remember, I'm going to put this up here just for let's see, how did I do that? I'm going to even, I'm trying to think back to lesson 2. Remember that if you get this situation where your index is even, the exponent is even, and you get an odd as a result, we need those absolute value bars. So I'm just checking here because that may come into play on number 4. I have a cube root here, so remember that I don't have to worry about it because it's not even. So on a problem like this, you can do this separately. You can simplify this one separately and this one separately and put them together. I think it's easier, though, to multiply everything together as it is and then simplify second. So 3 times 2 is 6. 7 times 21 is going to give you 147. Is that right? 7 times 21 is 147. So I have the square root of 147. And then I'm multiplying. So x to the 3rd times x to the 3rd. We add our exponents, x to the 6th, and then y squared. Okay, so 147 divided by, let's see, 147 divided by 4, 147 divided by 16, 147 divided by, there it is. Okay, it took me a while to figure out what 147 breaks down into. But what I can do now, this is square root, so I have, this 6 is always going to be hanging out, and it's going to get times by whatever I simplify 147 to be. Now, I figured out on my calculator that the square root of 147 can break down into 49 and 3, which breaks down into 7 and 7. And so those are my prime numbers there. I'm looking for pairs since it's a square root. Remember, there's really just a 2 there, so there's my pair of 7s. So I really have 6 times 7 now. This 3 goes back inside the square root symbol. And now I have a 6, right? So what's the square root of x to the 6? So 6 divided by 2 is 3, so that's x to the third. And then I have a y squared, and since the square root of y squared is just y, I'm going to clean this up, so I'm going to get 42, 6 times 7, x to the third, y, and left over is just radical 3. Now, I mentioned this here. I do have an even. I took an even, so if I go back to the problem here, this is a 2, that's even, and look, I got odd answers, so I need to put my absolute value bars around that, so this would be my answer for number 4. All right, so now we're going to get into, so these were, the first 3 were kind of multiplication. We're going to get into division, or dividing, and they can be written 2 different ways. If you have a square root, let's say you had the square root of 1/4, okay? You can, in math, you go back to your Algebra 1 rules, you can square root the top and square root the bottom separately, which would give us 1/2 here, right? So on this one, on a problem like this, what you always want to look to do is you always want to look to, I always do, I always look to reduce first. What I mean by that is 12 divided by 3 is 4. X to the fourth and 1x on the bottom gives you x to the third. So really this problem, before we even start messing with it, can reduce to 4x to the third. And that's going back to our rules that we learned in lesson 2 and lesson 1. So the square root of 4 would be 2. I can take an x squared out of that because there's really a 2 there. So I can take, oops, that's not right. This would be this, okay? Because this is, I'm taking the square root of x, so if you think about it like this, there's 3 x's, this is really 2, I'm looking for groups of 2, there's just one group of 2, so that's why I crossed that out, and that leftover goes back in there, and that would be my answer, okay? Now, even, odd, so that rule, I don't need any absolute value bars, I'm good to go with that problem right there, okay? Now on number 6, 4th root over 4th root, so I can simplify this. I could, if I wanted to, write this as one big giant 4th root. If you wanted, if it's easier on your eyes, you can do that and then simplify that. So 1024 divided by 4 gives me 256. So the 4th root of 256. I have 15 x's on top and 1 on the bottom, so that's going to leave me with 14 total on the top. And there's no denominator anymore. And so now we're taking the 4th root of 256. Now, again, I'd always take and try it, see if I can get the 4th root of 56, see if it works. It does, it's 4. So I don't need to break down 256 because the 4th root of 256 is just plain old 4. There's nothing left over. X to the 14th to the 4th root, so I always just go, you know, how many, 14 basically divided by 4. So 4 goes into 14 how many times? How many groups of 4 are there in 14? Well, there's 3, right? And you get 12 and you have 2 left over. So this is going to be x to the third because there's 3 groups of 4 in 14 with 2 left over. So that becomes the 4th root of x squared. Now, let's check to see what we have here. I have a 4 and a 4, and I got an odd out. So I'm going to have my absolute value bars around that portion, and that would be my answer there. Okay. Moving on to rationalizing the denominator. You did this in Algebra 1. So when you look at a problem like this, we talked about how you can make one big square root. You can also have broken up like that. Now, the whole point of rationalizing the denominator is this. You can never have a square root in the denominator for a final answer. Okay? So anytime you have a square root in the bottom, you have to get rid of it. It's just a rule in Algebra 1 and in Algebra 2 and then really as you go on. So here's how we rationalize the denominator. All you do is multiply whatever the denominator is. You multiply the top and bottom of that original by the denominator. And here's what's going to happen. We just multiply straight across. So you get the square root of 15 over. Now, what's going to happen is we're just going to get plain old 5. The whole point of rationalizing the denominator is to get rid of this square root symbol. Well, what's the square root of 5 times the square root of 5? It's really the square root of 25. Well, what's the square root of 25? It's just 5. Okay? and this would be my answer. Now, I will have students who will try to take 15 divided by the square root of 15 and divided by 5 and tell me the answer is the square root of 3. You can't do that. That's not a 15, it's the square root of 15. So you can only divide, if I had this, oops, there's a 5 there. If I made a problem up like this, the square root of 15 over the square root of 5, okay, that is the square root of 3 because they're both square roots. But you can't make that a square root of 3 there, okay? Again, on number 8, I would, since these are both square roots, I would reduce this. This is going to be basically x squared on top because I have x to the third and x, okay? 2 and 10 is going to give me basically 1/5, right? And then I have that y on the bottom. So I'm going to keep those square roots there, all right? So I simplified first, and then I got to get rid of this. So I'm going to multiply the top and the bottom by the square root of 5y, and we multiply straight across. Since these are both square roots, I can get 5x squared y, the square root of that, over 5y. Now, we have to simplify this because I have, if you look at, I can't simplify 5, but x squared, the square root of x squared, I can take out. So this answer is going to be x times 5y. And because there's really a 2 here and that's even, I got to odd, it's got to be the absolute value of x times 5y over 5y. And that would be my answer for that problem there. Okay. One more here at the bottom, number 9. Cube root and cube root. Again, I would simplify this first. Since they're both cube roots, I can simplify this, divide by 2, and you're going to get 2 there. Divide by 2 here, and you're going to get 3x. Okay. Now, this is one that students make a lot of mistakes on. Okay. Whatever this is, whatever this index is, it's these problems. I'm going to kind of zoom out a little bit here. These rationalizing the denominator, this concept is going to carry over to number 9. The problem is a lot of students are just going to do on this problem, number 9, what they did on 7 and 8. And so they're going to look at this and they're going to, oh, my denominator is the cube root of 3x, so they're going to do this. The problem with that is when you multiply these together, you're going to get the cube root of 9x squared. Well, this is the cube root of 9, and that doesn't get rid of the denominator. So you need to multiply it again. This shortcut, you probably figured out what it is if I zoom back in. Whatever the index is, when you go to rationalize the denominator, there should be a total of whatever the index is, right? Because what's on these problems up here, throwing my pen around, there's really a 2 here, the square root. Well, look, we have 1, 2, okay? So the reason that you need to do 3 of these is because 3 times 3 is 9 times 3 is 27, right? So on the denominator, here's what the denominator really looks like. I'll just draw it over here. The cube root of 27, x times x times x, x to the third. Well, what's the cube root of 27? It's just 3. What's the cube root of x cubed? X. So now we've gotten rid of the cube root. On the top then, we have 2 times 3, which is 6, 6 times 3, which is 18. So we have the cube root of 18, okay? And then we have x squared. Now we have to try to break down 18, right? 18 is 9 and 2 and 3 and 3. But when you break down 18, remember we're looking for groups of 3, and there are none. So our final answer would just be the cube root of 18x squared over 3x. And that would be our final answer. All right? Again, this takes some time to get used to doing these, and I'd be happy to help you out in class if you have any questions over the notes or over the assignment. Take care.